Hi everybody, this is Jim Kemp with 705 CNC. Hey, I've got another old Arburg here that is due for some new controls. So this one has been used a lot. In fact, it just got pulled out of service. It just made a run of 15,000 parts, but it's just getting to a point where this thing is getting so nasty and old. It's due for an upgrade. So we're going to do the Raspberry Pi upgrade to this thing, and I'm going to walk you through the steps and show you how we're going to go about doing that. So first let me walk you around this thing, and we'll show you a classic old Arburg that is in pretty rough shape. Thanks a lot. So like I said, I think this control box was an add-on. There's a company here who's got their sticker. I think they would take these things, import them from Germany, and then add these controls. So this is what's been running on here up to this point. So pretty rude and crude. We'll open this up and look inside in a second. So at some point this temperature controller was added. It actually works pretty decently, I guess, but yeah, still a mess. There used to be a box underneath here. It was on here that would detect the parts falling through with a photo eye, but that crapped out about 3 months ago. So we retrofitted in a relay here, which, yeah, there's a standard banner photo eye shooting through here now that hits this reflective tape on the far side. Of course, you know, these used to be aluminum fingers in here, but we replaced those with 3D printed. So that breaks the photo eye across here. So, you know, yet another kludge in here. Of course, these solenoids really got to go. These things leak. They've got, you know, some Scotch-Brite for mufflers taped across them. It's just kind of a mess. So yeah, here's our air manifold. Some classic Harbor Freight. And then we did this a few years ago. This is pretty embarrassing, but it's got a little Arduino down in here. So this did double injection. So, you know, if you didn't have a big enough shot size, you could wire this in line with the solenoid, and it would inject and then wait a while and then inject again, so that you could get a bigger shot. So yeah, it's got a little 110 volt power supply in here, an Arduino that drives a little relay bank here in the back, so all underneath a little hinged cover. So yeah, you know, you put this in line with the solenoid when you needed it. So this thing is seen better days. Made in West Germany. Classic. So back in the Ronald Reagan days, if you're familiar with the United States politics. So yeah, it's got a gate on here. So the gate makes a switch here. There's also I guess interrupts the air here. So we're gonna upgrade all this stuff. So yeah, we've got this thing for like a week or two. We've got to get this upgraded and back in service, because this thing needs to keep making parts. So this is what the inside of the enclosure looks like for the existing. And you know, back in the day, this looks like it was done pretty nice. I mean, somebody put some serious time and effort into making this pretty decent. So, but obviously over the years it's just gotten more and more hacked. Like this thing, I don't even know what this is for, what this does. Here's the back end of that temperature controller. Yeah, maybe, oh, this is the solid state relay for the temperature controller. So the temperature controller puts out a signal to this guy, and then it switches the 110 volts going up to the heater band. So yeah, poor old thing. It's definitely seen better days. I guess all these, well, this temperature thing, it doesn't work. But short of that, these two clamp timers and inject timers actually work. They're the hot ticket. So this thing is pretty simple. So this thing is pretty dead simple. It's just got a solenoid down here for the clamp. It's got a clamp close switch to let you know that the clamp is closed, that something's not caught in it. It's got a heater band, 110 volts. I think this is like 400 watts or 600 watts. It's not a lot. It's got a thermocouple back here to measure the temperature. Then another solenoid up on top here to do the injection. And that's about it. Oh, it's got the safety switch here to let you know the gate is closed. And then, of course, the part detect down here again. So in terms of I/O, it's about as simple as you can get. So here's most of the parts I ordered. I think every one of these came from Amazon, and we'll just go over them real quick. So here's the enclosure. Just a big plastic box for the Raspberry Pi. We've got some terminal strips with some breakers, the Raspberry Pi itself, some more terminal strip back here, a beacon, a couple of power supplies, opto rack, new temperature controller, and this is a little external hard drive basically for the Raspberry Pi. So instead of using an SD card, we're going to use a solid state drive, so it'll be more robust. This is about as small as you can get. I think it's 256 gigabytes. And then Raspberry Pi touchscreen. So we've got the Raspberry Pi already mounted on here. So now we're going to go through and start mounting all this stuff up. So yeah, I got some prices here for you. Enclosure, 60 bucks. The beacon back there, 15 bucks. Some toggle switches down in here. Those were 9 bucks. The aluminum rails, those are 10 bucks. 25 amp breaker, 10 bucks. Just some spare wire back there, it was 15. 10 amp breaker was 10 bucks. Let's see what else we got on this side. The little aluminum enclosure for the solid state drive, 17. The actual board inside was 15. Temperature controller back there was 40 bucks. This little piece of terminal strip was 23. The roll of wire back there was 18 bucks. This opto rack, 60 bucks. And then the Meanwell power supply was 23 bucks. And I already had the 24 volt one. I'm not even sure I'm going to put that in there. I don't think I need it. So all together, I think this was about 350 bucks worth of stuff I got from Amazon, and that'll do the bulk of it. There's still a few items remaining. There's an e-stop coming, and I think that might be it. So yeah, we're going to throw all this together as a new control box for it. So made some progress this week in getting this control panel together for the Arburg. So just thought I'd give you a quick inside. So got the external hard drive, SSD, going instead of using the micro SD card that the Pi normally runs on. I've had nothing but bad experience with the SD cards going bad in the Raspberry Pi. So, but these external hard drives are near bulletproof. So, spent just a ton of time getting this temperature controller mounted. Getting that hole exactly right without having any gaps around it is a major pain in the neck. But got that done, and got a lot of the controls in here mounted now. So, and just started some of the wiring. So it's coming along pretty well. Got a schematic going for it. It's going to make it pretty decent too. So more to come on this, I guess. So stay tuned. We'll start getting this thing wired up and running. Just for comparison, here's the original control panel I built for the first Arburg. Pretty small and basic. So this is the opto rack that drives a few outputs. Meanwhile, power supply, solid state relay for the temperature controller. And this is a little board I built that would catch the part detect. So the part detect, which was just a mechanical switch, was so fast that oftentimes the Raspberry Pi wouldn't catch it. So this little board just stretches the pulses out. So yeah, it's just a pretty basic little box. And then of course on the other side we've got the Raspberry Pi doing all the heavy lifting. So this is the end of the day. You can see it's about 6 o'clock and we ran just shy of 1,000 parts today. So this little machine gets a lot of use. So we've almost got, the bottom tub is completely filled and this tub is about 25%. So making these little Santoprene grommets, looking to make 15,000 of these. So eventually we're gonna have to find a way to sort these things. I don't know, maybe get a grill from a barbecue. Hopefully these things fall through and the grommets don't, so we can just shake them through. Otherwise you got to pick out 15,000 runners out of all these. Hey, I thought I'd make a quick follow-up video. This thing's coming along pretty nice. Got most of the inside done now. So got, let's see if I can show this. So over here we've got the hard drive now and a little 3D printed cradle, which is taped into place. I've got all the wiring done on the back of the temperature controller. The Raspberry Pi's got all its wiring in place now, so that's pretty well done. You can see the red light here on the solid state relay is coming on and off. That's under control over here from the temperature controller. I've got both power supplies in now. 24 volts is in place, so that's going to power our part detector, which I'll show later on, probably in a separate video. And last but not least, we now have a separate thermocouple. This is actually a Max 6675, I believe, that reads a K-type thermocouple. So another little part from Amazon. So this is really inexpensive. It just converts the cold junction K-type thermocouple into a digital reading that goes through a SPI cable into the Pi. So over here on the front display, we'll have this temperature reading that you could put one of the thermocouples. You could wire that into the mold base or any temperature you wanted to monitor. So this is of course the heater bands and controls the heater bands, but this one will just let you monitor any other temperature that you want to keep an eye on. So again, this is X. Well, I changed this a little bit too. So now you can go into auto cycle and it does its normal thing. So you can see it injecting, and then the mold opens and it should auto recycle and start another cycle. So I've got these cycles really short, so you can see that happening. So if you turn, let's let this cycle finish. If you turn auto cycle off, now you're in semi-auto, so it will complete the cycle and just stop. So if you want to make another part, now you're in auto cycle, which will then auto, after this part ejects, it will automatically continue on. But if you want to make a single part, you would, after you hit, you put it in semi-auto, and then it'll finish the part and stop. So after this one completes, let's see, it's all done there. So now if I wanted to make another part, I would hit auto cycle and then just go back into semi-auto. So it'll again complete this part and then stop. So this is a new little feature added. So of course, when you're making any part, you can always hit cycle abort and it'll turn off the injection and turn off the mold clamp. So, one new little added feature. Hang on, I'll come right back. Okay, one last feature is we've added this beacon on top. So just to test it, I threw an extra screen on here. So now if I press this beacon test, you see the red beacon coming on. If I try the horn, so haven't added that into the software yet at all. So we'll have to add that. So if a part doesn't get ejected and the machine is just waiting, we'll turn the horn on and the light. Maybe chirp the horn with the light stays on so that you can see the machine is stopped. So this is the Arburg wiring diagram. So I'm using a program called KiCad, and this is really made to do circuit board layout stuff. But in a pinch, it'll work just fine for making a schematic for the Arburg. So over here we've got 110 volts coming in. We've got two breakers. One breaker is going to be 25 amps, and that's just going to be to supply the heater bands. So that's going to go down here to the temperature controller and the SSRC, solid state relay, and that's going to go out to the heater bands, and then there's a thermocouple feedback. So I still haven't put the switch on the door yet, but this will, so this is a PWM, or pulse width modulated output, that goes to the solid state relay, and I'm going to interrupt that path with a switch so you can either enable it or disable it with a switch on the door, which is kind of nice. So then we've got a 10 amp breaker that supplies everything else. These are the Meanwell power supplies, 10 amp and a 2 amp 24 volt. And then here's the opto rack, right? This is the opto isolator rack that basically takes the low level output from the Raspberry Pi, which is over here. These are all 3.3 volt signals coming out of the Raspberry Pi, and they go down to the opto rack here, and then that switches the 110 volts that goes out to actually controlling things outside of the control panel. So, and then over here is the small little, this is a tiny little board that converts thermocouple into a digital signal, which the Raspberry Pi reads over a SPI bus. So then here's just a blown up picture of the actual, this is the connector on the side of the Raspberry Pi, and this is showing all the things that are interconnected to it. So this prints out on 11 by 17 paper pretty well. So, and this is all open source free software too, so you could take this and modify it. So I just wanted to show that.